let's do our first 3D program. So I want to run this program to see what it looks like. So what you want to do is you want to download the source code from my website and open it. So if you're using Visual C++ Express, this will be a quick refresher on how to create a project so that you can edit and run a program from my website. So I'm just setting up this project right here. I have to set up some properties real quick. Imaginary line to your eye, and it'll take the intersection of that line and this screen right here. So it'll come up with this blue point right here, which is in pixel coordinates. It'll do that for all three vertices of the triangle, and it'll draw a 2D triangle connecting the three pixel coordinates. So that's basically how it works. Now let's just take a look at the code. The first thing you'll notice is this right here, this license, which says you can use it for free, even in commercial projects, which is cool. And I'm just going to skim through this. You'll notice that there are lots of comments. That's because this is the first project and we want to make sure we know everything. Subsequent projects will have comments, but not tons and tons of comments. And the first thing we do in this project is, if we're on Mac, we include these two OpenGL header files, and otherwise we include this one. Then we have this line here that says using namespace std, which makes it so that we don't have to keep typing std::: everywhere. For instance, rendering function, which sets up some 3D rendering parameters. And we have this call right here, GL enable GL depth test, which we'll have in all of our 3D programmings because we always want it. You don't have to worry too much about what it does. It makes it so that if you draw something in back of something that you previously drew after, then it'll make it show up behind that object. So you'll notice that the call begins with GL because it's an OpenGL function. Then we have the handle resize function, which is called whenever the window is resized, and it gets the width and the height of the window. And this won't change much through our different projects, so we don't have to worry about it. You should notice, however, this GLU perspective call, it has a few parameters. This parameter right here, which is the angle that the eye sweeps. This angle right here. By the way, you'll notice that no matter how far away the screen is from the eye, Any 3D coordinate will map to the same 2D coordinate as long as the eye angle remains the same. So then we have this parameter quads to start drawing quadrilaterals, and we specify the 4 coordinates of the vertices of the quadrilateral using calls to GL vertex 3F. The 3 stands for the 3 coordinates, and the F stands for floats because we're passing floats. And you'll notice that after every decimal here I have an F. That just forces the compiler to treat it as a floating point number rather than, say, a double. And I don't think that you need it, but I'm going to be putting it everywhere just to make things explicit. And then I call GLEnd so that we tell OpenGL that we're done drawing quadrilaterals. Every call to GLBegin has a corresponding call to GLEnd. Then we want to draw the pentagon and the triangle, and we're going to break up the pentagon into 3 smaller triangles, which is pretty standard for OpenGL. So we're going to specify the 9 coordinates of the 3 triangles, and OpenGL will automatically group these into groups of 3. So each group of 3 represents 1 triangle, which we told OpenGL that we're drawing triangles right here. And then we want to draw the triangle, so that's another 3 calls to GL vertex 3F, and then we have a call to GLEnd because we're done drawing triangles. And finally we call glet swap buffers, which just sends our 3D scene to the window. And now we have our main function, which starts by initializing some stuff in glet. By the way, you'll notice that these functions here begin with glet instead of GL. We also had GLU perspective, which begins with GLU. That's because they're with the OpenGL utility and OpenGL utility toolkit. I won't worry about the differences among glet, GLU, and OpenGL, but we'll just call whatever we need to call, whatever the function happens to be named. So here we set up glet. We have a window that's 400 by 400. We create a window, and we call the init rendering function that we saw earlier. Then we point glet to our 3 functions, the function that draws the scene, that handles keys that are pressed, and that handles when the window is resized. And finally, we call glet main loop, which tells glet to take over control of our program. It'll take care of redrawing the window whenever it has to, and calling handle key press and handle resize when a key is pressed or the window is resized. And this function will never return. It'll just keep on going. The only way we'll exit our program is in handle key press when we had that call to exit. And finally, we have this line return 0, which all it does is it stops the compiler from complaining at us because int main has to return something. But this line never gets reached because the program spends all of its time in glet main loop. And that's how our first 3D program works.